brain is doing at the moment. Okay, I'm still testing my sound and everything. There should be about 5-6 second delay. So then I can just talk to myself in theory if I'm using the correct microphone. This is probably how many balls we got in the air, like projects and things to do. But let's focus on one thing at a time. Okay, those are essentially testing how well the new models are doing. So we have a bunch of new models that we are trying out. Yeah, so wherever we have a description for a web application, we'll be popping it into one of the bots, improve the description, and then into the code generation models. This won't be everything we do is deployed on the website eventually. Again, just testing the models, see how good they are. And it's the usual question of do we design something from scratch or do we improve something we had working prior? I'm not sure. So I have a bunch of things in the works. Some of them are broken. Oh yeah, Claude was actually able to fix this Venn diagram. Ooh, there's some problem with it. It should be a simple one to fix. I assume the new models, code generation models, will do a better job at this. Let's actually we haven't done this for a while. Let's do a quick chat with the new voice model. So do you know what the Bionic Chaos is?
Bionic ears, commonly known as cochlear implants, are electronic devices that can provide a sense of sound to people who are profoundly deaf or
No, I
severely hard
said
of hearing.
Bionic Chaos. Can you look it up? Single C. It's a website.
I couldn't find a website called Bionic Ears. Perhaps you meant the Bionic Ear Association, which is a community for cochlear implant users. Their website is advancedbionics.com. Alternatively, the Bionics Institute in Melbourne focuses on medical device development and can be found at bionicsinstitute.org.
Now, can you find something with Bionic and Chaos combined into one word, single C?
I couldn't find a website or resource called Bionic Chaos. Could you provide more context or clarify what you're looking for?
Do you have web access?
Yes, I do. If there's something specific you'd like me to look up, just let me know.
Yeah, look up that name.
I couldn't find a specific resource called Bionic Chaos. Could you provide more context or details about what you're looking for?
Can you try the same name with .com?
It seems I'm unable to access the page at bionicchaos.com. You might want to try visiting the site directly in your browser.
Yeah, the site is working fine.
It's possible there might be a temporary issue on my end. You can definitely try visiting bionicchaos.com in your browser to see if it's working for you. If you have any other details or something specific you'd like...
Okay, that was a bit annoying. Let's actually bring it back in here. Yeah, I did find it. What are you talking about? It's the same website name, but instead of 2C, it has only 1C.
The website bionicchaos.com offers various tools and resources for biomedical data. It includes interactive tools related to neurological data, cardiovascular studies, biomedical imaging, mental health, and more. You can check it out for detailed biomedical data analysis and educational resources.
Right, that's the one. Can you see the front page, the landing page? Can you go over some of the links on the landing page?
I can't interact with the website's interface directly. However, if you tell me about any specific links or sections you'd like to explore, I can help describe what they might contain or assist with any related questions.
Wait, you said you can access the website before.
I can open and view websites, but I can't interact with them in the way a person can, like navigating through links or interacting with dynamic content. If you need information about the website's content or have specific questions,
Okay, what's on
feel
the
free to
landing
ask.
page? What's on the landing page?
The landing page of bionicchaos.com features various sections and tools related to biomedical data. Here are some highlights: neurological tools, interactive tools for EEG and neuro-related studies, cardiovascular tools, resources for heart, ECG, and PPG analysis, biomedical imaging, tools for various types of medical imaging, mental health, resources and simulations related to mental health, simulations and games, interactive simulations for learning and research, data analysis and AI, tools for data analysis and artificial intelligence applications. There are also specific featured tools like Breast and Cyst, a dataset for medical image processing, EMG hand simulation tool, interactive tool for exploring EMG signals, interactive Venn diagram of AI types, engaging tool to learn about AI and its subcategories, e-brain visualization tool. Let me know if you need more details on any specific section. A 3D
Can you open the first link on the landing page?
I can't open specific links directly. If you have a specific URL, you can provide it and I'll try to access it for you.
Can you access the XML, the sitemap of the website?
I'm unable to access the site's XML sitemap. If you need help with anything else, feel free to ask.
Okay, what's the most interesting tool on the bionicchaos.com that you can find?
One of the interesting tools on bionicchaos.com is the EMG hand simulation tool, which allows users to explore electromyography BMG signals interactively. It's designed to help understand muscle activity and hand movements, which can be valuable for both educational and research purposes. Another notable tool is Seizure Zone, a 3D brain visualization tool for studying seizures. This tool can be particularly useful for understanding neurological conditions and for medical training. If you have any specific interests, I can provide more details about these or other tools.
Okay, can you provide more details on Seizure Zone?
I'm unable to open the specific URL for Seizure Zone directly. However, Seizure Zone is described as a 3D brain visualization tool that helps in studying seizures. It's useful for understanding neurological conditions, providing visual insights into seizure activity, and can be a valuable tool for both medical training and research. If there's anything else you'd like to know, feel free to ask.
We are live streaming together on YouTube at the moment. Are you happy to be a co-host?
That sounds exciting. I'm here to help with anything you need during the live stream. What would you like to discuss or do together on the stream?
Well, so we're developing this website that I was asking about. Are you happy to do that?
That's fantastic. It sounds like an exciting project. I'm happy to assist with any questions or tasks you have related to the website development. What specifically would you like help with?
Okay, I think I kind of need you to be able to access the website. Can you do that?
I can help you find information or details about websites, but I can't interact with them in the same way a person can. If you need information or guidance, feel free to ask.
Okay, what else can you find on bionichaos.com?
On bionicchaos.com, you'll find a variety of tools and resources. Here are some highlights. BreastumStist, a binary classification dataset for medical image processing. EMG hand simulation tool, an interactive tool for exploring EMG signals and muscle activity. Seizure Zone, a 3D brain visualization tool for exploring different brain regions. Interactive Venn diagram of AI types, a tool to explore the intersections of AI, machine learning, and computing. PulseViz heart rate visualization, a synthetic PPG waveform visualizer. Hearing Test, an interactive tool for measuring hearing thresholds. Cochlear Simulator, a visualization tool for exploring the electrical signals sent by cochlear implants. Datasaurus Dozen Visualization demonstrates how datasets with identical summary statistics can have different distributions. If you have any specific tools or sections you'd like to know more about, feel free to ask.
Where do you pull, where are you getting this data from? Are you actually, it seems like you are interacting with the website.
I can access and view the content of websites to gather information. This includes reading the text and summarizing what I find. When I mention specific tools or features, it's based on the information available on the site. If you need more details about anything, feel free to ask.
I have some broken tools that are deployed. They're not listed on the front page that I need to go over. I have this Python script that's actually testing crawling the website and telling me which links are broken or have any issues with them. Can you help with that?
While I can't interact with your Python script or directly test the links, I can certainly help you understand how to approach fixing broken links. If you have a list of links that are broken, you can share them with me and I can provide suggestions on what might be causing the issues and how to fix them. If you need guidance on debugging or any other aspect, I'm here to help.
Okay, how do I actually share stuff with you? Do I need to stop the audio chat, the voice chat?
You don't need to stop the voice chat. You can simply describe the issues you're facing or share any specific details here. If you have particular URLs, error messages, or descriptions of the broken links, you can type them out, and I'll do my best to help you troubleshoot.
Yeah, we have a bunch of these broken links that we need to go over and eventually
Got it.
deploy stuff on the website. I mean, it's already deployed. Yeah, we need to fix it and redeploy.
I understand. To help with fixing and redeploying, you can start by listing the broken links and their corresponding issues. If you need specific advice on debugging or addressing common problems, feel free to ask. Once the issues are identified and resolved, you can proceed with redeploying the updated version of the website. If there's anything specific you'd like guidance on, just let me know.
Forgot about this one. Yeah, we had so many of them. Keep forgetting which ones we were working on.
No worries. It's easy to lose track when there are many tasks. If you have a list, or if there's a way to retrieve the list of broken links, that would be helpful. Otherwise, we can start by focusing on any major issues you remember, or by checking the most critical areas of the site first. If you need help organizing or prioritizing the fixes, I'm here to assist.
Yeah, think about it. Yeah, this one, Paint, for example, this is something the new O1, O3, yeah, O3 Mini. Don't remember which model was doing it, but yeah, it did a really good job.
It sounds like there's a specific tool or feature, possibly related to Paint, that didn't perform well on certain models, like the O3 Mini. Identifying which models or versions have issues can help narrow down the problem. If you remember more details or have specific error messages, that can be useful in diagnosing and fixing the issue. If there's anything else you recall or need help with, let me know.
I was actually saying it's working pretty well, not on touch screen, only on a larger screen.
Ah, I see. Well, on larger screens, but not on touch screens. This could be related to differences in how touch events are handled compared to mouse events. You might want to check the touch event handling in the code and ensure it's optimized for touchscreen devices. If you need specific tips on improving touchscreen compatibility or any other help, just let me know.
Yeah, instead of trying fixing those, we might go for a new one. We had a bunch of images of what an application is looks like, and now we have a description. So then the question is, do we describe the web application like from images and stuff? The description is pretty accurate. Now the question is, should we be writing a brief for the developer to do all the coding, or should we just do it as we go?
If you have a clear vision of the web application and accurate descriptions, it's often helpful to write a brief for the developer. This brief can serve as a roadmap, ensuring that everyone is on the same page and that development proceeds smoothly. It can include details like functionality, design elements, and specific requirements. However, leaving some flexibility for adjustments as you go can also be beneficial. It ultimately depends on your workflow and how detailed you want the initial guidance to be. A combination of a solid brief with room for iterative improvements might be a good approach. If you need help drafting the brief or deciding on key elements to include, feel free to ask.
Yeah, I might close that one. because we're obviously not getting anywhere with it. Just go for the brief. Yes, we have a description for a web application. Should we read it quickly? We need to change it first before we actually develop the HTML. But yeah, maybe first, can you just do continuous text that is suitable for text-to-speech summary of this web application? Don't include any code in your response. We just want the we're gearing towards writing a brief for a developer to do all the coding. It should be a HTML and JavaScript, ideally vanilla. But first, can you just give a quick summary of what this web application will be doing, and also describe the layout of how, you know, the main components on the screen. Let's see if 4.0 is still good enough. Should be good enough for text descriptions like this. Okay, yeah, let's read that one quickly.
This web application is designed for real-time EEG signal monitoring and brain activity analysis. It provides users with a comprehensive view of brain rhythms, cognitive states, and signal quality, making it suitable for researchers, healthcare professionals, and wellness enthusiasts. The core functionality includes visualizing live EEG signals, performing spectral analysis, and offering insights into concentration and relaxation levels. It also features automatic detection of artifacts and prompts users to address signal quality issues when necessary. The application integrates seamlessly with EEG devices and offers the ability to customize recording parameters.
Okay, on the device, the bit with the devices, yes, integrating with devices is fine, but can we have a mock-up of it? We essentially want to stream data from a pre-recorded data file. So we'll have an EEG data file, and we want to stream from it as if it was hardware connected to a machine.
Such as time intervals and amplitude scales. The layout is clean and intuitive, with 3 main sections displayed on a single page. On the left, there is a panel dedicated to live EEG signal visualization, showing raw data from multiple channels, such as O1T3 and O2T4. Users can adjust the time window and amplitude scale via drop-down menus above the graphs. The center of the screen focuses on brain rhythms, represented by a color-coded area chart that dynamically shows the relative contributions of alpha, beta, and other brainwave frequencies over time. This section also highlights artifact areas with clear warnings when signal quality is compromised. On the right, a spectrum analysis panel displays frequency domain data for each EEG channel, with bar graphs showing the power of various brainwave bands. At the bottom of the screen, a separate panel provides real-time metrics for concentration and relaxation levels, depicted as line graphs to track changes over time. The application is controlled through a top navigation bar, which includes buttons for starting, stopping, and resetting the recording, as well as options for connecting devices, generating reports, and accessing a manual. Device information, such as the connected device's name and battery status, is displayed in a compact section on the top right corner of the screen. The design ensures that all critical data is accessible at a glance, enabling efficient monitoring and analysis of brain activity.
Well, yeah, that description sounds good. Yeah, we would like to be able to stream from file as if we have a device connected. So we'll need to change the interface accordingly and make it clear so we know where is it streaming data from. Now, yeah, so essentially the main purpose of this web application is a kind of different display of the different frequency bands. Yeah, so if we can focus on that from the images, if you can describe in more detail. And yeah, we want to write this text as if it was instructions directed at the developer. So it will be a prompt that will be sending a developer to do all the coding. But this prompt should not include any code. If 4.0 is still... Yeah, it's doing the simulated data streaming. That sounds good. File streaming mode. Raw EEG, visualize EEG signal from multiple channels. We have this data set with 16 channels in it. And that one is of high quality EEG. So we have the data on our machine. We might treat it as if we are streaming it into this web application. Yeah, the panels, if we can somehow make it work on mobile as well, so it should work okay on different screen sizes. So essentially, if you have a very wide screen, you will have the 3 panels. If you have a vertical screen, then we should stack them vertically. Otherwise, stack the panels horizontally. And yes, if there is enough space on the screen, we should have more options as to what panels we want to show. So essentially an option to hide the panel, hide and show different panels. Yeah, there's essentially left, middle, right, bottom panel, and file management. Streaming control. That's all sounds really good. Yeah, if you can add instructions about this, the development stack, we want essentially HTML and JavaScript, vanilla as possible. I mean, ideally the data will be in a JSON file, so we might have to convert the data first. Don't actually remember what format it's currently in, but yeah, we'll have to check, and we might deal with it later. We have some other web applications on the website that are actually using the data. We haven't touched them in a while. Yeah, I have this EEG data visualizer. yeah, that's using those 16 channels, and it's just being streamed from file. I think we used to have a backend. We don't want, ideally, we don't want the backend. We want the preloaded data file, so we don't want to strain my server. Yeah, that the old application that we have is relying on the backend. It's called Flask. It's a Flask web application, so it has quite extensive backend. So we actually trying to prevent that. So the data files should be loaded in the front page as well, in the front end as well. So can we somehow modify the instructions to address all that?
Web application development instructions. File-based EEG data visualization platform. Overview. This web application will visualize high-quality EEG data from a pre-recorded file in a simulated streaming mode, supporting up to 16 EEG channels. The app will provide real-time visualization of EEG signals, frequency bands, and cognitive metrics, optimized for both desktop and mobile devices. Unlike previous versions relying on a backend, e.g. Flask, this new application will be entirely front-end based, using HTML and JavaScript, vanilla, to handle data processing and rendering. The data file will be preloaded and streamed directly on the client side, avoiding any backend infrastructure. Key functionalities. 1. Simulated file streaming. Load EEG data from a pre-recorded file directly into the browser. Simulate real-time streaming of EEG data from the file back, displaying data channel by channel as if it were coming from a connected hardware device. Allow adjustable playback speeds, e.g. 0.5x, 1x, 2x, and support seeking to specific timestamps. 2. 16-channel visualization. Display raw EEG signals for up to 16 channels in real time. Ensure that the application can handle high-quality EEG data seamlessly, including signal visualization, spectral analysis, and cognitive metrics. 3. Customizable layout and panels. Dynamic, responsive interface that adjusts based on screen size. Desktop widescreens. Panels arranged horizontally in 3 sections, left, middle, and right, with an additional bottom panel. Mobile vertical screens. Panels stacked vertically to optimize usability. Allow users to show or hide individual panels, e.g. raw signal, brain rhythms, spectrum analysis, cognitive metrics, to customize the view. 4. Frequency band analysis. Provide a real-time area chart showing contributions of different frequency bands, alpha, beta, theta, delta, for each channel. Dynamically update as data streams to reflect changes in brain rhythms. 5. Cognitive state metrics. Display concentration and relaxation metrics derived from frequency band proportions. Provide a clear, time-based line graph for these states. 6. File management and streaming controls. Include an intuitive file management system to upload and preview EEG files. Allow users to start, pause, and stop the stream. Adjust playback speed. Seek to specific timestamps within the file. Clearly display the file name and streaming mode status, e.g., streaming from file name. 7. Mobile and desktop responsiveness. Design the app to work across devices. Desktop, widescreen layouts with simultaneous display of all panels. Mobile, vertical stacking of panels with the ability to toggle visibility. Use CSS media queries or JavaScript to dynamically adjust layouts based on screen size. Technical stack and development requirements. 1. Front-end only architecture. No back-end. All functionality, including file loading, data streaming, and processing, should occur on the front end. The EEG data file will be loaded into memory and processed directly in the browser using JavaScript. 2. Development stack. HTML, structure and layout of the application. CSS, styling and responsiveness, including media queries for different screen sizes. JavaScript, handle, file loading and parsing, simulated streaming of EEG data, real-time updates to visualizations. Use a JSON format or other structured format for the EEG data file, ensuring compatibility with the visualization functions. 3. Performance considerations. Efficient handling of large EEG files, leveraging in-browser memory. Optimize rendering performance to ensure smooth updates for all 16 channels, even during fast playback. 4. Data handling. Assume the EEG data file is pre-processed and formatted, e.g. JSON, CSV. Include fallback mechanisms for unsupported or corrupted files. Store the entire EEG dataset in memory to eliminate the need for external requests. Interface design. 1. Top navigation bar, file management controls, upload button, streaming status, and file name display. Playback controls, start, pause, stop, and playback speed adjustment. Options to show hide individual panels. 2. Left panel, raw EEG signal display. Display waveforms for all 16 channels in a scrollable or paginated layout. Allow customization of time intervals and amplitude scales. 3. Middle panel, brain rhythms. Area chart displaying the relative contributions of alpha, beta, theta, and delta waves over time. Include percentage labels and a legend for clarity. 4. Right panel, spectrum analysis. Bar graphs for each channel showing the power of different frequency bands. Highlight peaks, e.g. alpha or beta waves, with tooltips. 5. Bottom panel, cognitive metrics. Line graphs showing concentration and relaxation levels over time. Include brief explanations of how metrics are calculated. 6. Responsive layout. Desktop, arrange left, middle, and right panels horizontally with the bottom panel displayed beneath. Mobile, stack all panels vertically with toggle options to show hide panels for a cleaner interface. Instructions for the developer. 1. File streaming simulation. Implement JavaScript logic to simulate streaming data from the preloaded EEG file. Use intervals to feed data in chunks to mimic real-time streaming. 2. Panel customization. Add toggle controls in the top navigation bar for users to show or hide individual panels. Ensure panels resize dynamically based on available screen space. 3. Responsive design. Use CSS media queries and JavaScript to detect screen size and adjust layouts accordingly. Optimize for mobile devices by stacking panels vertically and minimizing clutter. 4. Data visualization. Use Canvas or SVG elements to render EEG signals, area charts, and bar graphs. Ensure smooth animations and real-time updates for all visualizations. 5. Error handling. Validate uploaded files to ensure compatibility. Provide user-friendly error messages for unsupported formats or corrupted data. Key objectives. Fully front-end based application with no reliance on a back-end or server-side infrastructure. Smooth and responsive visualizations for up to 16 channels of EEG data. Easy-to-use interface with clear options for file management, playback control, and panel customization. Let me know if you need further clarification or additional details.
Okay, so there's a couple of things that stand out. Yes, so the cognitive metrics, obviously, that's the, the ultimate goal is showing those. So we're showing concentration and relaxation levels over time. I don't know, how can we need the detailed description of how that is gonna be calculated and displayed on the chart. So can you expand on that one?
Ah, cognitive metrics, concentration and relaxation levels. The cognitive metrics, concentration and relaxation, are derived from the EEG frequency band data. These metrics will provide users with a clear understanding of their mental states over time, presented as dynamic line graphs that update in real time alongside the streamed EEG data. Below is an expanded description of how these metrics will be calculated and displayed. 1. Calculation of
Okay, so we have the original instructions. Trying to add some details as to how the concentration and relaxation levels are being measured. Okay, will we be updating the instructions later on in this chat? But first, we also need to address the point, what will happen if we do not have a data file uploaded into the system? So first of all, we will need to generate the file and folder structure, ideally a single folder, simple file structure, but also we would like an option to have a JSON file with simulated EEG data that we could use so that the web application working as is, even if there is no data file being selected. Even though there's no data file present in the folder. So we want like a simulation mode. Then we would have reading from file, streaming from file mode, and then eventually streaming from a device. And we'll have a drop-down selection for devices. Can you address those in the chat before we modifying the whole set of instructions for the developer?
Hashed additional details for the web application instructions. Handling the absence of a data file. To ensure the application remains functional even when no EEG data file is uploaded, we will implement a simulation mode as a fallback. This mode will allow the application to operate with preloaded simulated EEG data stored in a JSON file within the project folder. The steps for addressing this are outlined below. Simulation mode. 1. Purpose. Provide a default operational mode when no external EEG data file is uploaded. Simulate realistic EEG signals for all 16 channels. Ensure the user can still explore the interface and visualizations without interruption. 2. Implementation. Include a JSON file named default simulation data JSON in the project structure. This file should contain pre-recorded EEG data for 16 channels, formatted for easy parsing, frequency band data and timestamps to simulate real-time streaming. The application will automatically load this file in simulation mode if no file is uploaded. 3. Behavior. Upon startup, the app will check if a file has been uploaded. If no file is present, the app defaults to simulation mode and loads default simulation data.json. Display a notification to the user, e.g., no file uploaded, running in simulation mode with default data. Hash file streaming mode. 1. Purpose. Allow users to stream data from an uploaded EEG file. Replicate real-time streaming behavior using pre-recorded EEG data. 2. Implementation. Provide an upload file button in the navigation bar. parse the
uploading a file. Don't worry about uploading the file. Yeah, we have that as an option, whatever. But to begin with, when the page load, we just want to go for streaming the default simulation data, which we will also have instructions, a prompt instruction to generate a simulated EEG data, and we'll be just using that as default. So essentially we want to include in the instructions something like down the line that when we're loading the web application, it should just be streaming, showing data, playing data, scrolling data on the screen, and updating all the different panels. And what else we've got? Yeah, so everything else seemed to be okay. Also the structure, so obviously index HTML is required, that's good. Styling, the JavaScript. Then we have the data. That data folder, I don't think we need a separate folder for it. Just have the JSON file, call it eeg.json, just have it in the main folder. And we also don't need the assets folder. We also don't normally use a readme file. We have what's called an info text file, which will actually include the instructions for the developer and the file and folder structure. So single folder, we can turn the thing into a single folder. So just a single HTML, single CSS, single JavaScript, single JSON file. That's pretty much it. Yeah, so I trust you can do that. So how about we just go ahead and update the full set of instructions for the development of this web application. And yeah, just give a detailed overview of what it does. Yeah, key functionalities. Yeah, make sure everything is included. Yeah, the technical stack could just mention, vanilla HTML, CSS, JavaScript, and JSON file. If you also could include a paragraph on essentially instruction of how to generate the simulated EEG signal, that would be good. Yeah, the section on the interface design looks perfect. Don't forget to mention responsive layout, so it works on mobile as well. And again, so the streaming will be happening from the default simulated EEG file. And as you load the application, it should be streaming straight away. So yeah, if you can rewrite the whole complete standalone set of instructions, just remember do not include any code in it. So just text, and make it as clear and as detailed as possible. While it's generating, go check out the website. Everything we develop on the website eventually goes onto this website. So, and it's currently all under development. We'll be cycling through these things. So the things at the bottom is stuff that we developed about 2 years ago. If you have any priorities, do let me know. But we'll be essentially going over them again, trying to make them better with the new code generating AI models. So we'll be using currently we're using 4.0, but then eventually pushing it towards 0.1 or 0.3, and essentially see which one can produce better code. So that's the plan. And yes, we also have a bunch of tools currently in development that we also will be looking at. And yeah, again, writing a description for a developer and probably just doing it from scratch as opposed to trying to fix existing code seem to be much easier. If we wrote everything in the description, in the brief for developer, and it's absolutely clear and covers everything, then in theory, the hypothesis is that these new AI models, not sure which one, that one says great for coding. But is it an overkill or something? I'm not sure. Well, it's pretty complicated. A set of instructions. Let's just go over it briefly. Mainly, yeah, we have one of each. That's good. Info text. Yeah, it's following instructions. It's not hallucinating on us or anything. We have this web application development, EEG data visualization simulation. So that sounds good. Simulate the EEG data. Instruction for EEG data simulation. Yeah, we have the bands seem correct. Alpha, beta, delta, theta. Wave-like oscillations, several minutes, loopable is a good word. Do we need a prompt like that? You're an expert developer specialized in creating clean, efficient, modern web application. Complete self-contained HTML files that include all the necessary. Yeah, I'm not sure how it's gonna go about it. This meant to be standalone. Meant to be standalone. Next steps: generate the simulation and store it in. Implement responsive UI. Test. Play with control. Yeah, I mean, looks pretty good to me. So let's just pop it. Let's just do 0.1 first, because that's also the one where we might be facing some restrictions, usage restrictions, even though we are paying for it. So it's doing its reasoning, because that's essentially what's gonna replace me. Okay, that's generating the code. It's a pretty complicated project. I'm just making sure. Yeah, there are placeholders placeholders. That's should be okay. And no placeholders in CSS. Drawing or small chat library, if allowed. What do you mean if allowed? Why wouldn't you be allowed? Optionally validate or transform the data. Start streaming interval. All drawings here is extremely simplified. For smoother waveforms and real-time charts, consider incremental updates or advanced plotting techniques. Okay, not sure about that. Here's a small sample. Okay, so it's simulating a JSON EG file. Now there's only one way to test it. Can you suggest short name for this web application? Make it plural. NeuroStream is a good one. Let's go for NeuroStream. And let's see what it can do. Okay, shall we? Yeah, I seem to have all the code. Okay, we have the NeuroStream info text. And then we'll just have all the instructions, 140 lines. Should have the file and folder structure. So I have NeuroStream. In the same folder, we have index.html, style CSS, obviously. App.js. EG.json. It generated the sample EG as well. Okay, now we have all the files, they're empty files. We just make a copy of it and we call this one O1. So we have NeuroStream, GPT O1. We have a copy of this theme. While it's generating, let's also do O3 mini. just pop the instructions. And hopefully it will just start developing. And we have in O1 and the index HTML. We have the styles, styling. Then we have JavaScript. Actually has some placeholders, but we'll just see how we go. We have a JSON, which is a sample EEG data. And this should be it. Okay, Auth3 is Auth3 Mini is generating stuff as well, so we'll have another copy. We'll call it the GPT O3 Mini. That finished generating. Let's check what O1 have done. Okay, that's a bit weird. There's no errors. Where's the EG? I don't see the EEG waveforms. Why? Is that? Wait, is there meant to be something that the EEG is just like flatlining on me or something? It might be flatlining on me. But anyway, that's what O1 have done. Let's see. Maybe the simulate that the EG is not long enough or something, but it's like flatlining on me. There are no errors. It's flatlining. The EG signal is not actually, it's showing a flat line. There are no error messages. Everything else seemed to work okay-ish. So this was O1. Okay, instead of trying troubleshooting, we'll just give it to another model, and that's O3 Mini. O3 Mini. Care about what it's saying. We have HTML. We have styling. Keep it simple. We have our JavaScript. Seem to be complete. And we have a JSON file, e.g. JSON. JSON cannot have comments. JSON cannot have comments. I don't know why it's generating, why it's being lazy. Are you being a bit lazy? It's generated only minimal EG data. Okay, this is O3 mini. What? Um, I'm not sure. Like, I don't even know. I don't even know how to describe it. Yeah, the brain rhythm's meant to be this amplitude thingy. So yeah, would make more sense have it vertical. But never mind, let's just trust the system and do another one. With O3 mini high. It says great for coding and logic. Should we also tell it to generate all code and not be lazy? Not sure. Well, let's not bias it. Let's just give it the same brief. Okay, we have O3 mini high. Still planning. Maybe it's not a bad thing. Ooh, that was quick. That was quick as. Okay, we have HTML. A CSS. App. The JavaScript. JavaScript seemed to be a bit too short, but okay. Just have to trust the system. The JSON file. It's giving next steps as well, but I was kind of hoping. Ah, okay, this is nice. I like it. Yeah, I like the being a different display. We need to specify though what the Y and X axis mean on the cognitive metric. Can you generate a larger, more realistic EEG data? It's interesting. It's a PhD level stuff. The user wants larger, more realistic EEG dataset. JSON before I dive in, I need to consider what dataset should feature several minutes of EEG, including 16 channels. Should be loopable. Time series segments beyond the initial sample. Yes. 30 segments for more realistic and measurable size. Each segment will have timestamps, 16 channel, voltage in microvolts, and frequency bands. Likely sine waves with some noise for realism. Generating about 60 segments, each with 16 channel values and frequency bands. Yeah, reason for 1 minute. Oh, doesn't have image. It does not have image. Would be interesting if it just went 4.0. So I had this web application made for me by another developer. Can you look at the front panel and tell me what the issues might be? Just go over each panel, tell me what might be happening, what might be wrong, and how it could be improved. Yeah, we don't need human developers, do we?
From the uploaded screenshot, the application consists of several panels and sections. Here's an analysis of potential issues and improvements for each panel. Hash EEG signal, 16 channels, panel. Observations. The panel appears to be empty, with no visible data or activity shown. If it's supposed to display live EEG signals, the absence of data could indicate issues such as data not being streamed or loaded correctly. Visualization issues, such as incorrect scaling or lack of proper rendering. Suggestions for improvement. 1. Debug data feed. Ensure that EEG data is being streamed and processed correctly from the backend. Verify that the signals are mapped to the correct channels and are in real time. 2. Visualization enhancements. Add placeholders or loading indicators when no data is present. Provide clear labels for each channel and ensure that the grid layout effectively separates them. Use a time series graph or line plot to display EEG signals for each channel. 3. Error handling. Show error messages if data is unavailable or the system encounters issues connecting to the source. Brain rhythm analysis panel. Observations. A bar chart is displayed, indicating delta, theta, alpha, and beta rhythms. However, there's no accompanying legend or detailed explanation of the values. Suggestions for improvement. 1. Add context. Include a legend or tooltips that explain what each brainwave band represents, e.g., delta for deep sleep, beta for focus. Label axes with units or percentages for clarity. 2. Dynamic updates. Ensure the bar chart updates dynamically and smoothly to reflect real-time data. Consider adding animations to help users perceive changes over time. 3. Visual clarity. Use consistent and distinguishable colors for each rhythm and make sure color contrast is high for readability. Indicate whether these values are averages, peak amplitudes, or power spectra. Cognitive metrics, concentration and relaxation panel. Observations. A scatter plot with 2 dots, red and blue, is shown, but no scale or labels are provided. The purpose of the plot is unclear. What do the red and blue dots represent? Suggestions for improvement. 1. Clarify purpose. Provide a title or subtitle within the panel to explain what concentration and relaxation metrics are and how they are computed. Add axes with proper labels and units to define the plot area. 2. Improve interactivity. Include tooltips when hovering over the dots to display specific values. Add a trend indicator or trail to show changes in the metrics over time. 3. Provide thresholds. Use zones or thresholds in the scatter plot to visually indicate high, medium, or low levels of concentration relaxation. Spectral analysis panel. Observations. A single orange bar is displayed, but its meaning is not clear. There is no additional context or labels. Suggestions for improvement. 1. Explain the visualization. Provide a title or legend that explains what the orange bar represents, e.g., power spectrum intensity. Label axes or provide numerical scales to make the data meaningful. 2. Enhance functionality. If this is a frequency spectrum, consider using a line plot or heat map to show frequency changes over time. Allow zooming or panning for detailed inspection of specific frequency bands. 3. Provide real-time updates. Ensure the spectral analysis updates in real time and synchronizes with the other panels. General observations and suggestions. 1. User interface, UI. The overall layout appears functional, but could benefit from more visual hierarchy and spacing. Add a central legend or help section to guide users in understanding the metrics and their significance. 2. Interactivity. Include pause, play, or reset buttons for each panel to allow users to control the simulation independently. Provide an option to export data or capture snapshots for analysis. 3. Error handling. Add error messages or indicators to show when a data stream is interrupted or not functioning properly. 4. Responsiveness. Ensure the application layout adapts to different screen sizes for better usability on mobile devices. By addressing these issues and incorporating the suggested improvements, the application will become more user-friendly, informative, and visually appealing.
And a question, do I need to update any of the AVA files? Let's quickly use Gemini actually. Hey, what do you see on the screen?
The screen displays a user interface for EEG data visualization and simulation. It shows EEG signals from 16 channels, a brain rhythm analysis, cognitive metrics for concentration and relaxation, and a spectral analysis chart.
Does there any issues that you can see that are obvious?
Well, the spectral analysis chart indicates that it is a dummy signal. Also, the values in the brain rhythm analysis chart keep changing constantly, even though the EEG signal in the 16 channels shows no changes. Is there any other specific aspect you would like me to review?
No, I think you are spot on. We have a developer making this web application for us. It's using simulated EEG JSON file. Can you give them instructions as to how to improve the code?
I think you're right. The issues that I mentioned earlier are not good. You're developing this web application for EEG data visualization, and it's using a simulated EEG JSON file. Do you want me to provide some instructions to improve the code?
No, what you mentioned earlier was good. Can you turn it into a prompt for the developer to improve the code based on what you mentioned before?
Okay, so you would like me to convert my previous observations into a prompt for the developer to improve the code based on what I mentioned before. I can do that for you. I will make it a prompt for the developer. The spectral analysis chart is labeled as a dummy signal and doesn't represent real data. Also, the brain rhythm analysis chart values keep changing constantly, while the EEG signals from the 16 channels are not changing at all. This should be addressed in the code to reflect real EEG data processing. Is there anything else I can help you with?
Now that's perfect. Thank you. Let's put it back to O3 Mini.
Below is an updated version of app.js that addresses your concerns. In this version, spectral analysis. Instead of using the 16 channels instantaneous values as a dummy signal, we now maintain a short history buffer of one channel's channel 0 data. A simple discrete Fourier transform, DFT, is performed on that history so that the spectrum panel reflects a frequency domain view of the data. For a production application, you might swap this with a proper FFT.
Okay, let's do this again. Okay, what do you see on the screen?
I see a visualization of EEG data. There are several panels showing different aspects of the data, including EEG signals for 16 channels, brain rhythm analysis, cognitive metrics, and spectral analysis. Is there anything specific you would like to focus on?
Yes, can you go over each panel and tell me what might be wrong with it and in general for the whole
Sure.
application?
Okay, let's go over each panel. The EEG signal 16 channels panel shows the raw EEG data from 16 different electrodes. Each channel displays a fluctuating waveform, which indicates the electrical activity in different areas of the brain. In general, these waveforms should vary as the simulation changes, but in this case they appear flat, which might suggest a problem with the signal or simulation.
Okay, can you provide the instructions for the developer as to how to improve the EEG simulated waveform?
Okay, for the developer, to improve the EEG simulated waveforms, they should make sure that the EEG signal channels in the top left panel are showing fluctuating waveforms and not flat lines. Currently, all the channels are flat, which is likely an issue with the simulation.
Okay, it seems like the developer added some noise to the signal. Is it any better now?
Yes, it appears the developer has added some noise to the EEG signal channels. The waveforms are no longer flat. Is there anything else you would like to discuss about this application?
I would actually would like to instruct the developer to actually change the simulated EEG signal so it's working better with this type of visualization. Any instructions? Can you write a set of instructions for the developer?
Sure, I can provide instructions for the developer. The main issue is that the simulated EEG signals should not be a flat line. The developer should ensure that the simulated signals in the top left panel have a fluctuating waveform, as this would make the simulation much more realistic.
It seemed to be changing the code instead of changing the JSON file, e.g. simulated data. Can you give them instructions to change the data instead of changing the code?
Okay, I see. Instead of changing the code, the developer could explore altering the JSON file that contains the EEG simulation data. This would allow for a more flexible way to adjust the simulation and potentially achieve the desired fluctuating waveforms without having to modify the underlying code.
Okay, I did adjust the JSON EEG file. Is it any better now?
Okay, it seems like adjusting the JSON EEG file has improved the simulation. The EEG signal waveforms now show dynamic fluctuating lines. Is there anything else I can help you with?
Well, yeah, but the problem is seem to be the spectral analysis doesn't seem to change much. So essentially, the bands are not fluctuating enough. We would like to improve. We would like to instruct the developer to improve the EEG simulated data, make it longer, not just the so don't make it looping. Can you instruct them not to loop it, but make it longer and actually make it fluctuate? Each delta, theta, alpha, beta should be fluctuating some more, so we can actually see more changes in the cognitive metrics and the spectral analysis. Can you write this set of instructions? Wow. Okay, we have the transcription because Gemini just failing on us.
Below is a set of instructions you can provide to the developer to improve the simulated EEG data without altering the visualization code. The goal is to create a longer, non-looping data set where each EEG channel and frequency band, delta, theta, alpha, beta, fluctuates dynamically. This, in turn, will drive more noticeable changes in the cognitive metrics and spectral analysis panels. Instructions for improving the EEG simulated data. 1. Extend the dataset duration. Generate more segments. Instead of using a small set of segments that simply loop, generate a dataset that covers several minutes or longer of simulated EEG data. Continuous data. Create a continuous sequence of data segments rather than a loop. This helps simulate a real-time, ongoing EEG recording. 2. Enhance dynamic fluctuations in EEG channels. Introduce oscillatory components. For each channel, incorporate an oscillatory component, for example, a sine wave, into the simulated values. Use different phase offsets or frequencies for each channel to avoid uniformity. Add random variations. Along with the oscillatory component, add a controlled amount of random noise so that the values vary over time and do not appear flat. Realistic value ranges. Ensure that the channel values remain within realistic limits. E.g., if using a 0 to 20 range, the fluctuations should stay within these bounds. 3. Improve frequency band data. Dynamic band values. Instead of static or minimally varying numbers, generate frequency band power levels, delta, theta, alpha, beta, that change over time in a realistic manner. Derived from signal variability, consider simulating these band values based on the underlying fluctuating EEG signals. Alternatively, generate them with their own oscillatory patterns and random variations so that they're not constant from segment to segment. Impact on derived metrics. Ensure that these dynamic band values meaningfully influence the cognitive metrics, concentration from beta power and relaxation from alpha theta averages, and the spectral analysis panels. 4. Update the metadata and documentation. Application title header. If appropriate, update the title or header in the application to reflect that the EEG simulation data has been improved for increased realism. Developer documentation. Update any accompanying documentation, such as info.txt, to note that the EEG dataset is now longer, non-looping, and features more realistic, fluctuating values for both the raw channels and the frequency bands. 5. Testing and validation. Visual confirmation. After updating the JSON file, test the application to ensure that the top left EEG channels panel now shows clear, fluctuating waveforms rather than flat lines. Metric responsiveness. Verify that the cognitive metrics and spectral analysis panels display dynamic changes in line with the new, more realistic data. Iterate if necessary. Fine-tune the simulation parameters, oscillation frequency, amplitude, noise level, etc. in the JSON generation process until the fluctuations look realistic and drive meaningful changes in all panels. By following these instructions, the developer can adjust the EEG simulation data in the JSON file to be longer, non-looping, and dynamically fluctuating. This approach ensures that the visualization panels, especially the spectral analysis and cognitive metrics, respond to realistic variations in the simulated EEG signals without needing to change the underlying display code.
At the EEG, the JSON file, the EEG JSON file should just have time series data, no frequency bands or no other data. So if we can rewrite the description in the canvas and explain what did you change in the chat, explain in the chat what changes did you make in the canvas. But yes, in the canvas we want to make sure that the JSON file includes only time series data for the 16 channels, and we would like it to cycle through like concentration and relaxation, like medium to begin with, then concentration high, relaxation low, then relaxation high, concentration low, and so on and so forth. Make it cover all the options. So if you can change the instructions, don't include any code yet, just change the instructions in the canvas to address that. Can you do that? Yes, it seemed to have been a too difficult task for 4.0. I know we haven't tried 4.0. We did it with 0.1, 0.3 mini, and 0.3 mini high. Yeah, 0.1. It didn't do a great job. No, I don't like it. So might as well get rid of it straight away. And then we had 0.3 mini. Yeah, no, there's some problems with the EEG. There's no option to hide certain panels. So yeah, we get rid of all 3 mini as well. So we got left with our template, empty files. And whatever all 3 mini high did. We updated the instructions.
I've updated the instructions to reflect your request, removing frequency bands and ensuring the JSON file only contains time series data for 16 channels. The document now also specifies cycling through different brain states like concentration and relaxation. Let me know if any further refinements are needed.
I didn't 4.0 is yeah, it's a bit funny. It didn't do what we asked for. It's a bit silly. It's like an undergrad student or something. Sorry for all the undergrad students, but I don't think any undergrad will be able to do any of this. Now let's upgrade to, let's go for a, let's go for, we can't switch. Okay, that's not good. We need like a master's level, so we need like 01 or 01. Let's go for 01. Or one doesn't have the canvas options, does it? No, it should. But yeah, 4.0 was a bit hopeless. Yeah, if we're placing it in the canvas, we still have 01 options. The EEG in the JSON file. EEG files should just have time series. There are no frequency bands or no other data that that's the JSON. Okay, let's do this. And what's reasoning about? Because I haven't provided any prompts.
Hello. I see you've provided detailed instructions for developing a web application to visualize and simulate EEG data in real time. How can I help you further with these instructions or the implementation? Feel free to let me know if you'd like example code, design suggestions, or any other assistance.
Okay, 01 is a bit slow. "17 seconds, reasoning." By the way, everything we do is available on bionicears.com. Go check it out. And don't forget to provide your feedback. Yeah, 01 is not much smarter.
Your instructions have been updated in the document to ensure the JSON file only contains time series data for the 16 channels and cycles through various concentration relaxation states. Let me know if there's anything else you'd like to change.
No, I mean, it's better than 4.0. I would have expected to remove all that. Wait, it did? What? It's a bit weird. So instruction for EEG simulation, it had this do, which, yeah, it did remove. It's just when you hit editing, that's not correct, but the instructions are correct. Okay, now I'm confused. Anyhow, in the chat alone, can you provide a summary for this web application and what it does?
Summary of the web application. This front-end only web application simulates real-time EEG data streaming from a preloaded JSON file, eeg.json, containing time series data for 16 EEG channels. It displays the live-like signals in scrolling waveform plots and optionally calculates on-the-fly metrics like frequency band power and cognitive states, concentration, relaxation, to mimic different mental conditions. Users can pause, resume, and adjust the streaming speed, toggle which panels are visible, waveforms, spectral analysis, concentration relaxation graphs, and seamlessly cycle through various simulated brain states. The layout automatically adapts for desktop and mobile, and all processing occurs in the browser. No backend is required. The structure is also designed to be easily expanded with future functionality, such as loading user-provided EEG files or connecting to an actual EEG device.
Yeah, that was super quick.
Below is one complete example of how you might implement the project. This example follows the instructions and uses only HTML, CSS, and vanilla JavaScript. In your project folder, you would have the following files: /project folder, index.html, style.css, app.js, eeg.json, info.txt. Below are sample contents for each file. #1 index.html. This file sets up the basic structure and includes 3 panels. One for EEG signals.
Ah, yeah, it failed. Stopped reading, didn't it? That's okay. Because we just need the code. We have the same. A name for it, so we have HTML. We have our styling. I wish there was a quicker way of copy pasting. Have the JavaScript. How long the JavaScript is? It's a bit short. Looks a bit short. I mean, if we can do everything we need to do. Ah, yeah, that's exactly what we wanted. Yeah, so the EEG now is it's too short. The EEG might be too short. Why is the EEG so short? Don't be lazy. We need the whole code, yeah? But why is it unclear? Okay. EEG is sorry. Is too short. This should be better. Why is it timestamps? Um, what? You can use simple JavaScript sim to generate a longer EEG dataset. We have an EEG data generator, don't we? Yes, we do. But then that one had a backend. Yeah, it's just static like that. So yeah, you can adjust things, but hey, we want to automate this. Yeah, I don't like the structure of the JSON file. Yeah, I might reduce the number of channels. Probably don't need 16 channels for this example. Well, because the cognitive metric calculation would not be taking all the 16 channels. How is the cognitive metrics being calculated in terms of how many channels are being used for that calculation? And the signal spectral analysis as well. Is it only looking at one of the channels or all of the 16?
In the sample implementation provided, both the cognitive metrics and the spectral analysis are simulated, rather than derived from a detailed, channel-specific computation of EEG data. Here's a breakdown of how each is handled and how you might extend it for a more realistic analysis. Cognitive metrics, concentration and relaxation. Current implementation. In the sample code, the cognitive metrics are not actually computed from the 16 EEG channels. Instead, they are simulated using simple mathematical functions, sine and cosine based on the timestamp. Java.
Okay, we really need to change the whole set of these instructions. Can we make sure that the cognitive metrics and the spectral analysis are actually calculated from the EEG signal? Also, can we make sure that the EEG signal is going, that we have enough data in the EEG signal for about a minute worth of time series data? Also, how about we reduce the number of channels from 16 to say 4? Can you update all the instructions in the canvas to address this? Yeah, we're having trouble. Yeah, obviously the bot is not able to generate proper code if it didn't provide proper instructions, isn't it? So we're now using O1 to generate the instructions.
Your instructions have been updated to specify 1. 4 channels instead of 16. 2. At least 1 minute of continuous EEG data in EEG.json. 3. Both spectral analysis and cognitive metrics will be calculated on the fly in the browser from the raw EEG signals. Let me know if you'd like any further adjustments.
And let's go over the instructions again.
I've added a few comments and suggestions to help improve the writing quality. Let me know if you'd like any further edits.
I need them in the chat because the text to speech doesn't work in the canvas.
Here are the comments and suggestions that were added. 1. Section title. Consider renaming this section to Core Features to create a more concise heading and unify the style with other sections. 2. Smoother transition. Replace "This ensures users see" with "This approach allows users to explore" for a smoother transition and more active phrasing. 3. Combine setup details. It might be clearer to remove this detail or merge it with the "No backend is required" note to reduce repetition of setup requirements. 4. Playback control purpose. Add a brief mention of why users might adjust the speed, e.g., for closer inspection or faster review. 5. Avoid repetition. Replace "This ensures" with "These measures result in" to avoid repetition of "ensures" and emphasize the outcome.
Anyway, both of them are not good. We definitely can do much better. The sample per second, so there meant to be 60 samples in the timestamps in the JSON file. So why not just do it? Okay, we'll have to continue this next time. Don't forget to go check out the website. Everything we develop eventually appears on the site. This one here. And I'll see you next time. Bye.